What we'll discuss is that we start with fundamentals. Then important network theorems. Then two-port networks. Then AC analysis, resonance. Then we can have a responses, transient analysis, filters and attenuators. So in this sequence we'll prepare the subject. So whenever we consider about any network, then at that time we can consider that network will consist of three elements: resistor, inductor, and capacitor. So basically when we study network analysis, the important point is that to understand the basic understanding of what is the resistor, what is the inductor, what is the capacitor, because any circuit which is combination of resistor, inductor and capacitor. So whenever I will consider any circuit, it is generally combination of resistor, inductor and capacitor, where applied excitation will be there. That might be voltage source or current source. So voltage source is there, or you can have a current source. So basically what is a network? Network is basically combination of resistor, inductor, capacitor, where it is forming a closed path. So we can say that current always flows through the closed path. So let us try to understand the basic element as a resistor, and then we'll move towards the inductor and capacitor. So when we talk about resistor, many times there is always confusion in the mind of student that what is basically resistor, what is resistivity, and what is the resistance. So we can have a resistor. We can say that it is a circuit element. Then resistance, it is a property of material, or it is opposition to flow of current. To flow of current. And resistivity, it is a property of material. Material to oppose flow of current. So whenever we say about resistor, resistance and resistivity, then at that time unit of resistance is nothing but ohm, where I can say that I have some resistor having value R, this is length L, area of cross section is A, and some excitation is given to this. Then I can say that resistor of any material is proportional to length of the material inversely proportional to area of cross section. R is equal to rho L by A, which is given in ohm. Therefore resistivity is given in ohm meter. So basically this is the basic definition, that whatever resistor of material is there, that is directly proportional to length of the material inversely proportional to area of cross section, and rho is nothing but resistivity, which is given in ohm meter. In the form of field theory, I can say that J equal to sigma E is a point form of Ohm's law. But let us try to understand what is basically Ohm's law. So we can say that for linear elements, applicable to linear element. Now what is meaning of linear element? I can say that whatever resistor, inductor, capacitor, they are the linear circuit elements, because your output, whatever the output excitation is there, that is dependent on your input excitation. I can say that current flowing through resistor is proportional to applied voltage. So to any resistor, if I will apply a forcing quantity as a voltage, then current of I ampere will flow. So I is equal to, I is proportional to V. So I can say that on independent axis, voltage is independent variable on the x-axis, current is dependent on the y-axis. This is nothing but slope, which is equal to y divided by x. So I can say that I is equal to G into V, where G is conductance, which is reciprocal of resistance. So I can say that I divided by G is equal to V. So V is equal to I into R. Now many times in interviews they will ask what is the Ohm's law condition. So it is applicable to the linear circuit elements. Second important point is that whatever this Ohm's law is there, that is applicable to the linear elements where temperature is constant. It is not applicable to the non-linear circuit element. So if we consider non-linear element as a transistor, then at that time we can create a H parameter model, but we can't directly apply the Ohm's law. So Ohm's law is applicable to the linear circuit elements. So basically, whenever we talk about the network, then at that time resistor is one of the important element because it opposes to the flow of current. Now, whenever we say that I have given some voltage, that means basically I have given some forcing quantity to the circuit. So whatever this forcing quantity which is given to the circuit, so I can say that it is equivalent to forcing quantity. Current is a flowing quantity, and linear relationship between current and voltage is given by I is proportional to V. So V is equal to I into R, where V is nothing but V is given in volts, I is given in amperes. Now by saying this, what we want to do is that if any circuit will consist of number of resistors. So firstly let us try to understand this concept very clearly. So if any circuit will consist of number of resistors, then at that time how we can find out the equivalent current as well as how we can find out the voltage across the resistor. All these are very basic fundamentals but very important for the future exercises. So whenever we say that I have two resistors connected in series, R1 is there, R2 is there. This is my series circuit. Now there are a couple of examples which are in the examination which are based on this. Phi is there, I will flow. Now what is the first main important point? I can say that current flows from high potential to low potential. Flows from high potential to low potential. The way in which we say that temperature flows from hot end to cold end. So current flows from higher potential to the lower potential of the battery. V is nothing but your voltage source which is applied. Now whenever current will flow here, then at that time this current will flow, same current will flow through both elements because they are connected in series. So what is the meaning of series circuit? Series circuit means current remains same, current through all elements same, but what will happen now? If you consider this point, current is entering here, consider this point as positive, negative. That means there will be some drop across this element. This is V1. Again current is entering this point. This is positive, this is negative. There will be some drop across this element. This will be equal to V2. So I can say that summation of voltage around closed path is equal to 0. You can treat this as a Kirchhoff's voltage law. So I can say that whenever I am going from negative to positive, I will mark this convention as a plus V. Positive to negative, I will mark this convention as a minus V1. Positive to negative, I will mark this as a minus V2 equal to 0. That is summation of voltage around closed path equal to 0. Why closed path? Because current will not flow through the open path. Current always flows through the closed path from higher potential to the lower potential of the battery. V is equal to V1 plus V2. Now we know the Ohm's law. What is V1 now? V1 is nothing but voltage drop across R1. So I can say that V1 is equal to I into R1. V2 is equal to I into R2, which is voltage drop across R1 and R2. So V is equal to I into R1 plus R2. So I will get I is equal to V upon R1 plus R2. Now why this expression is important? This expression gives me total current which is flowing from positive terminal of battery to the negative terminal of battery. It is equal to V divided by R1 plus R2. Now what is V1? V1 is nothing but potential developed across R1. V2 is potential developed across R2. So I can say that V1 is equal to I into R1. V1 is equal to I into R1, which is equal to, what is value of I? Let us put value of I from this expression. What is value of I? V divided by R1 plus R2 into R1. This is equal to V1. Similarly, what is value of V2? V2 is equal to I into R2. I into R2. What is value of I? I is equal to V upon R1 plus R2 into R2. So what is the very important property of series circuit? Series circuit, if you observe these two expressions properly, then at that time one can say that V1 is equal to, V1 is voltage drop across R1, is total applied voltage V into same resistor value R1, applied voltage V into same resistor value R1 divided by R1 plus R2, summation of two resistors. Similarly, V2 is nothing but voltage developed across R2, which is equal to V into R2 divided by R1 plus R2. R2 divided by R1 plus R2. Now this is called as voltage division rule. Voltage division rule. This indicates that in series circuit voltage is divided. So what is the property of another property of series circuit? Fourth property I can say that voltage is divided and voltage division rule is applicable. Voltage division rule is applicable. Got this point? So don't say that voltage division rule is applicable to the parallel circuit, because in parallel circuit there will not be any current division, there will not be any voltage division. In case of whenever I have connected n number of resistors in series like this, Rn, R2, R1, V, then also voltage division rule is applicable. That is, voltage across any element is equal to total voltage into same resistor value divided by sum of resistors, and current flowing through all these elements remains same. Current which is entering at any point is treated as positive. This is sign convention. Current which is leaving at this point is treated as a negative, and KVL is applied. So I can say that we have said whatever KVL is applied in case of series circuitry. So property of series circuitry is that current flowing through all elements will remain same, whether it is resistor, inductor, capacitor. They are connected if they are connected in series, and voltage across the element is dependent on applied voltage. So this is about the series circuit. Now in similar way, I can say that whatever equivalent resistance is there, I know that. Now if multiple resistors are connected in series, from this expression, I can say that V upon I. Suppose I want to reduce this circuit into the equivalent resistance circuit between A point and B point. A and B. Voltage is applied as a V. This is current I. So I can say that V is equal to I into R equivalent. V is equal to I into R equivalent. Because R equivalent is nothing but equivalent resistance of this series combination. V upon I is nothing but R1 plus R2. So R1 plus R2. But what is R1 plus R2? This is V upon I, which is R equivalent. R1 plus R2 ohm. This is the equivalent resistance of the series circuit. So whenever n number of resistors are connected in series, I can say that equivalent resistance is equal to R1 plus R2 plus up to Rn. So that is addition of the individual resistor values. Now in similar way, let us try to understand that whenever two elements are connected in parallel, or more than two resistors are connected in parallel, then what will happen exactly in the circuit? So whenever two resistors are connected in parallel, voltage across every element remains same. So let us discuss on that. And current will be divided. But how? That we will discuss with some diagrammatical representation. So, second important point is that parallel circuit. R1, R2, they are connected in parallel. Parallel means I have a common terminal. The way in which electricity light comes to our electricity meter, where parallel connection is established. So, I can say that voltage V is applied. Due to that, current of I ampere will flow. Now, if you observe this circuit carefully, in between C point and D point, resistor R2 is there. In between A point to B point, resistor R1 is there. Now, one can say from this that these 2 points are same like these 2 points. These 2 points are same like these 2 points and these 2 points. So, voltage across every element remains same. So, what is first property of parallel circuit? Voltage across every element is same. So, I can say VAB is equal to VCD, which is equal to V. Now, what will happen here? If current of I ampere is flowing up to this point, current will be divided as I1, I2. So, current is divided. Now, this is the common point which we can treat as a node. Node is a point where number of branches will meet. This is one branch, this is second branch, this is third branch. So, current is divided. KCL is applied. What is Kirchhoff's current law? Kirchhoff's current law states that summation of current at any node is equal to 0. But this is partially correct. I can say that algebraic sum of current at any node is equal to 0. Now, what is the meaning of this? I will consider I is incoming current. Incoming current. Now, I1 and I2, these are outgoing currents. Outgoing currents. So, I can say that summation of current is equal to 0. So, I plus I. Why plus I? Because incoming current is treated as a positive. Outgoing current is treated as a negative. So, plus I minus I1 minus I2 is equal to 0. So, I can say that I is equal to I1 plus I2. What is value of I now? I want to find out value of I. I1 is equal to V upon R1 plus voltage divided by resistance is current flowing through this branch. Voltage divided by resistance is current flowing through this branch. So, I divided by V is equal to 1 upon R1 plus 1 upon R2. But what is I divided by V? If we draw the equivalent circuit of this, I divided by V is nothing but R equivalent. V is applied voltage. So, I divided by V is equal to 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2. So, reciprocal of resistance is nothing but your admittance or conductance. So, G equivalent is equal to G1 plus G2. But now, what is another important property of this circuit? Voltage remains same is first property, current is divided. Second important point is that if we consider this expression, I is equal to V upon R1 plus V upon R2, I can say that I is equal to V into 1 by R1 plus 1 by R2, which is equal to V into R1 plus R2 divided by R1 R2. So, I got the total current which is flowing through this closed circuit. Current is flowing from higher potential battery to the lower potential battery. Two resistors are replaced by a single resistor. So, R equivalent is equal, I is equal to V into R1 plus R2 divided by R1 R2. Now, I want to find out what is the branch current I1, branch current I2. What is I1? I1 is equal to V upon R1. V upon R1. Let us put value of V from this expression. What is value of V? V is equal to I into R1 R2 divided by R1 plus R2. So V upon R1 into R1 plus R1 R2 divided by R1 plus R2. R1 will cancel. Sorry, I into. So I into R2 divided by R1 plus R2. Now see this expression very carefully. I1 is equal to I into R2 divided by R1 plus R2. I2 is equal to V upon R2. Let us put expression V. I into R1 R2 divided by R1 plus R2 divided by R2. I into R1 divided by R1 plus R2. What voltage division rule for series circuit has stated? Voltage division rule states that voltage will be divided where total voltage across any element is total voltage, applied voltage into value of the resistance divided by sum of resistors. Now let us see. What is this now? Current is divided. So in parallel circuit, current division rule is applicable. Current division rule is applicable in case of parallel circuit. What this current division rule states? Whatever I1, I2 values are there, here current is divided, or current division rule. Total I1 current is flowing through this resistor R1, which is equal to total current I into opposite resistor R2 divided by sum of resistors. Total current opposite resistor R2 divided by sum of resistor. In similar way, current flowing through R2 is equal to total current into opposite resistor R1 divided by sum of resistors. So I into R1 divided by R1 plus R2. Now if you can have question that if n resistors are connected in parallel, what will happen? R1 R2 up to Rn. How we can apply a current division rule? Because there are common mistake in the examination in application of this current division rule only. So I1 is there, I2 is there. Now what you can do is that always remember, restriction on current division rule is that it is applicable to two resistors connected in parallel. So whenever more than two resistors are connected, then you can consider this is nothing but opposite resistor, which is parallel combination of R2 to Rn. So you can say that I1 is equal to total current I into opposite resistor R2 parallel with R3 parallel with up to Rn divided by R2 plus whatever this parallel combination divided by R1 plus R2 parallel with R3 parallel with Rn. So current flowing through I1 is equal to total current into opposite parallel combination of this, that is opposite resistor divided by sum of resistors. So we can say that current division rule is applicable. Now let us discuss some examples on this. So in examination, why this is important, or how we can solve the examples in very less amount of time. So we can say that somebody will say that okay, I want to find out the equivalent resistance between terminals A and B. Sometimes they will ask for 1 mark. So there are a couple of questions which are based on this. So 1 mark or 2 mark questions for gate. Now somebody will say, okay, I have in between A point and B point, R1 is there, which is equal to R, 10R, R and B. Now I want to find out resistance between A point and B point. What is the easiest method? To find out resistance between A point and B point, now we can have a very easy method. Let us try to consider that some voltage V is applied. Due to that, current of I ampere is flowing in a closed path. Current I is leaving, because current always take a closed path. So in 1 minute only, for 1 mark or 2 marks, we need to solve this question in 1 minute. So how we can solve this? Now both resistors are same. I can say that this is I by 2. This is I by 2, because I is equal to I by 2 plus I by 2. Now this current is leaving, current is I, so I can say that this is I by 2, this is I by 2. Now from this we can say that in between point C and D, current flowing is effectively 0. I flowing is equal to 0. That means this is nothing but your balanced bridge. Why is balanced bridge? The reason being, whatever these arms are there, they are having same resistance. So no need to apply star delta transformation, because yet we have not came across that. But no need to apply any complicated method. We can say that current is equal to 0 means this can act as an open circuit in between C point and D point. This is R, this is R, this is R, this is R, A point and B point. Now as I by 2 current is flowing here, I by 2 current is flowing here, R and R, they are connected in series. So I can say that, okay, 2R is connected across 2R. This R and R are connected in series. So in between A point and B point, R equivalent, RAB is equal to 2R parallel with 2R, which is R1 R2, 2R into 2R divided by 4R, which is equal to, effectively it will be equal to R ohm. So I will get the value of resistance is equal to R ohm, which is nothing but half of this 2 resistors. In similar way, if 2 resistors are connected like this, I don't have any resistor here, but these resistors are same, R, R, R and R. The resistance between point A and B, RAB, is equal to, now I can say that C and D point, here we consider as an open circuit because current is equal to 0. Still it is balanced bridge. These points are shorted. So equivalent structure you can draw as a R parallel with R in between C point and D point, R parallel with R, so I can say that R parallel with R is nothing but R by 2, half of this resistance, plus R parallel with R is R by 2, which is equal to R ohm. So in that way you can find out the equivalent resistance between point A and point B for the series parallel combination of the resistance, or by using series parallel combination of the resistance. Now let us take some other example. Generally there are a couple of questions which are there in GATE 2006, GATE 2003 and other examination paper. Suppose 1 ohm resistors are connected in a cube. Cube is like this. One ohm, 1 ohm, 1 ohm. B point is there. This is A point. I think this is from GATE 2006. For 2 marks, and same was there in GATE 1998 for 2 marks. Now whenever 2 resistors are connected in, whenever these resistors of 1 ohm or same value resistances are connected in the symmetrical structure like a cube, then we need to solve this in very less amount of time. Same process we can apply, that apply voltage, that is negative positive V. Due to that, current of I ampere will flow. Now this current will be divided into 3 equal branches because all resistors are equal. This is equal to I by 3, I by 3, I by 3. This I by 3 will be divided as I by 6, I by 6 in 2 equal branches, because 2 branches are having equal resistors, so current is divided as a half of the actual current which is flowing up to this point. Then this I by 3 will divide as I by 6, I by 6. I by 6 and I by 6 will become I by 3. Similar way, I by 6, this I by 3 will be divided as I by 6, I by 6. I by 6 plus I by 6 is nothing but I by 3. Now consider any path from A point to B point, because we want to find out what is the value of RAB. So from A point to B point, we can say that if we consider any path, phi minus, consider, suppose I will consider this path, phi minus I by 3 into 1 minus I by 6 into 1 because there will be some drop across here, drop across here, drop across here, minus I by 3 into 1 is equal to 0. So I can say that V is equal to I by 3 plus I by 6 plus I by 3. So I can say that V upon I is equal to 1 by 3 plus 1 by 6 plus 1 by 3. So RAB. Why RAB? Because voltage source is connected between point A and B. So RAB is equal to 1 by 3 plus 1 by 3, 2 by 3 plus 1 by 6, which is equal to 5 by 6 ohm. Very simple. So in 2 steps only you can solve this example instead of using series parallel combination. If suppose somebody will consider that, okay, somebody will say that, okay, I don't want to consider this branch. No problem. You can consider any branch. Suppose I will consider this branch. So again I will get same answer. V minus I by 3 into 1 minus I by 6 into 1 minus I by 3 into 1 is equal to B. Somebody will consider this branch. He will get the same answer. He or she will get the same answer. V minus I by 3 into 1 minus I by 6 into 1 minus I by 3 into 1. So I will get equivalent resistance is nothing but 5 by 6 ohm. So these are the very simple examples which are based on the basic fundamentals of series parallel combination of the resistance. Now there are a couple of questions which are based on infinite plane. So now if number of resistors are connected in infinite plane in the following sequence, in this fashion. It is extended in the north direction, south direction, west direction and east direction. In the infinite plane, resistor values are R ohm. All resistor values are same. Now suppose I want to find out resistor between point A and B. Now infinite plane is there. So it is very important to understand that current always take path of minimum opposition. First point. Current will never reach to the infinity. Because current always take path of minimum opposition. Whenever maximum opposition will be there, current will not flow through that particular path. So what we can do? The way in which we have applied voltage V here, in similar way, we want to find out resistance between point A and B. We can apply a voltage here, plus minus V. Now what will happen? If you observe this circuit carefully, then at that time, 4 resistors are there. So I can say that I by 4, I by 4, I by 4, I by 4. Current will be divided into 4 equal parts. Total incoming current at positive terminal and negative terminal should be same. So this current will be I by 4, I by 4, I by 4 and I by 4. So if you consider this loop or closed path is nothing but your loop. I can say that positive V minus voltage drop across this I by 4 into R minus I by 4 into R is equal to 0. You are reaching to the negative terminal of the battery. So I can say that V is equal to I by 4 plus I by 4 into R, which is equal to, but what is V upon I? Voltage source is connected between A point and B point. RAB is equal to R by 4 plus R by 4, which is equal to R by 2 ohm. So R by 2 ohm is nothing but resistance seen in between 2 points A and B for the infinite plane, where plane is extended in the north direction, east direction, south direction, west direction. I think this question has come in gate 96 for 2 marks. So these are a couple of questions which are based on the basic fundamentals of series parallel combination of the resistor. So without resistor, we can't dream any electrical circuit. We can have a LC circuits and other circuits, but basic element which we have understood, that is the resistor, and there are many examples which are based on the resistive network. So this is as far as finding out the equivalent resistance between 2 points is concerned. Now we got the equivalent resistance, we got the method to find out the equivalent resistance between 2 points. We understood about the series circuit and parallel circuit. Now what is main important point? Main important point before moving to the next topic is that suppose I have some network which consists of number of resistors, and I want to find out voltage across any element. How we can get this? Consider, suppose I have 1 ohm, 2 ohm, 1 ohm, 2 ohm, 1 ohm, 2 ohm, 1 ohm, 1 ohm. Now this circuit is there. I think this is for 2 mass from gate 97 and gate 92. Suppose somebody will say that I want to find out voltage V. Applied voltage is suppose 16 volts. Now how I can find out voltage V? Now whenever this kind of example is given, then what is expected from the student? Expectation is that in very less amount of time you can solve this example. Now how we can solve this example? Now don't apply any KVL to this loop, because you will get multiple equations. For this, suppose I will apply KVL, I will get one equation, second equation, third equation, fourth equation. Correct? Loop is nothing but your closed path, which is present in the circuit. Now what you can do is that you consider network up to this point. Now see, 1 plus 1, they are connected in series. So this current is equal to, suppose I1. 1 plus 1, they are connected in series. That is equal to 2. 2 parallel with 2 is equal to 1. Again 1 plus 1 is nothing but connected in series. That is 2. 2 parallel with 2 is equal to 1. 1 plus 1 connected in series. That is 2. 2 parallel with 2 is equal to 1. So reduce network up to X point. 1 ohm. 1 ohm. X point. Now this is 16 volts. This is the equivalent circuitry. Because series arm resistors are same, shunt arm resistors are same. Because this 1 ohm plus 1 ohm, this is contribution of 1 ohm is contribution in the series arm, 1 ohm plus 1 ohm is present in the shunt arm across this Z branch. Now you can say that I know what is the basic law. Basic law, I know that voltage is divided, because equivalent circuit is nothing but your series circuit. So voltage division rule is applicable. So by using voltage division rule, what you can say? By using voltage division rule, I can find out voltage Vx. What is Vx now? Vx is equal to 16 into 1 divided by 1 plus 1. 16 by 2, 8 volts. Now I got this potential Vx is equal to 8 volts. Now let us forget about this circuit. I got the potential at X, which is equal to 8 volts. So B step is that I can consider this point is Vx, 1 ohm. Now reduce network up to Y. What is the reduction of network up to Y? 1 plus 1, they are connected in series, that is 2. 2 plus parallel with 2 is equal to 1. 1 plus 1 is equal to 2. 2 parallel with 2 is equal to 1. So at Y point, again I will get a network as a 1 ohm. So I can say that Vy is equal to Vx into 1 divided by 1 plus 1, Vx by 2. What is Vx? 8 volts. 8 by 2, 4 volts. Correct? So at Vy I got a 4 volts. Now no need to write, because 16 is divided by 2, 8 volts. 8 is divided by 2. That is equal to 4 volts. Vz will be equal to 2 volts. Now 1 and 1 they are connected in series. So what is the value of V? V is equal to Vz into 1 divided by 1 plus 1. If we draw the network like this, 1 ohm, 1 ohm, this is V potential, this is Vz potential. If we cut network at this point, which is equal to, what is Vz potential? Vz is equal to 2 volts. So 2 divided by 2. Voltage is equal to 1 volts. So in only 3 steps you can get the answer that what is the voltage which is present across this particular branch.